So let's address this question on mensuration. The topic is cylinder. Okay. So the question is, find the capacity of a cylindrical water tank whose radius is given and whose length is given in meters. Okay. And since the question explicitly says cylinder water tank, the first thing that should flash in your head is, okay, they're talking about cylinder. Okay. So that's half battle won, because you don't have to guess what the 3D object is. Before solving, always read the question twice and check out and break it word by word and understand what they're asking about. So the first thing is they're asking to find the capacity. Capacity is nothing but volume. Okay, how much a particular object can store. That's another way of saying volume. So that means we know they're asking about volume, and we also know that volume is always measured in cubic units. So this we should not forget. Okay, and then we have been given the dimensions. So the best thing to do that is always have a visual. Okay, now we know that it's also a cylinder. Okay, so we need to find the volume of a cylindrical water tank. So we should always draw this visual here like this, so that okay, we know all the dimensions mentioned, what are the things we would need for a cylinder, and we need to find the volume. So we know that. And then what we do is we just solve the problem, because what is given is a radius of 2.1 meters and length is 5 meters. So the dimensions here, the units are in meters. So that's also given. Okay. Now let's kind of solve the problem. So let's start the solution. It's going to be a very simple solution. So we have this cylinder and we have been given radius is equal to 2.1 meter. So this particular thing is going to be 2.1 meters. Okay. And if you see this as a center, and the height is going to be 5 meters. Okay. The height of the cylinder, which is given by this, is going to be 5 cylinder. And the ask is, what is the capacity or what is the volume? Okay. So we know from the volume of the cylinder formula, volume of a cylinder is equal to pi r square multiplied by h, the height, cubic units. Okay. And if you plug in the values, 3.14 for pi, the radius is 2.1, and we have to square it up. So we need to take the radius twice, 2.1 into 2.1, and then the height is 5 meters. We take height and we multiply, we get in decimal, which is 69.23 cubic meters. Okay, since the unit is in cubic units, we need to put in meters, because that's what we have given. Okay, and that's the simple answer, and that's straight whatever marks it is assigned, 2, 3, 4, whatever that is. Okay, and like I said, if you don't memorize, or if you're not able to remember the formula, don't worry about that. Always remember this trick. Volume of any 3D object is always going to be, whether it's cylinder or a cuboid or any shape, it's going to be always the area of the base multiplied by the height. Whatever is the shape of the base, the area of that particular shape in the base multiplied by height. In the case of cylinder, we always know that the area of the base is going to be a circle, and then we already have the height here, and the area of the circle is pi r square, and then the whole overall formula becomes volume is equal to pi r square into h. So like I said, just remember this. If you don't remember, don't worry about it. Just think about it. Okay, anytime volume is asked, I need to just multiply the base of the object, whatever shape that is. In this case, it's circle, and I need to just multiply by the height. In case of cuboid, it will be just length into breadth into height, and so on and so forth. So that's how you need to solve this. So, and that's why I said mensuration is all about formulas, and if you remember the formulas, or if you know how to derive them on the fly, you can easily solve the problem. But don't do any calculation mistakes. Use calculator to solve all this equation. Okay, and don't try to forget to add the cubic meter. If the dimension is not given in specific units, just say cubic units. That should be all before we move on to the next topic.